Welcome back to Math 95, Section 4.1. We're going to continue our discussion on solving systems of linear equations in two variables. We've already checked in to see how an ordered pair could be a solution to a system of two linear equations. And we talked about solving a system by elimination. We've also talked briefly about checking a system by graphing. We will do a little bit more of that in this video as well. For now, I'd like to talk about the other method for solving, called substitution. That's where we're going to focus in this video. So, substitution is the other algebraic approach to solving a system of equations. And in it, we are going to isolate one variable in one equation and we're going to plug the expression into the other equation replacing a variable. So last time we were eliminating a variable. This time we're going to replace a variable. So to show you what that looks like, we're going to solve this system by substitution. So when you're doing this, it's really nice to pick easy choices. Easy choices are coefficients of 1 or -1. So I would like to isolate the y in this variable. It's going to be the easiest one to do. So to do that, I'm going to add y to both sides, and I'm also going to subtract 3 from both sides. So subtract 3 and subtract 3. So this is going to give me, for this equation here, I will have 3x minus 3 equals y. So the part where we do the substitution is I'm going to take this entire expression and I want to replace the y value in my other equation. So I'm going to take my 6x minus 4, but instead of writing a y, I'm going to put the 3x minus 3. That whole thing will still equal 10. At this point, I have an equation with only one variable that I can fairly quickly solve. So this is going to give me 6x minus 12x plus 12 equals 10. Negative 6x. I'm going to subtract this over here, equals negative 2. So x equals 1/3. At this point, the steps are identical to those for elimination. Once you have one of your two variables, you're going to plug that into one of your equations so that you can solve for the other variable. So we need to solve for y, and it doesn't really matter which of the two equations I plug this into. In fact, some of you, instead of checking, or as you check, some of you might like to plug this 1/3 into both equations and make sure you get the same y value out. That's completely legitimate. In fact, I think I'll do that this time. So I'm going to have 6 times 1/3 minus 4y equals 10. I'm also going to look at 3 times, I don't know what happened there, 1/3 minus y should equal 3. So in this equation, I'm not often going to have you work two equations simultaneously. This is just for demonstration purposes. In this first equation, I wind up with 6 over 3 is 2, minus 4y equals 10. Subtract the 2 away, negative 4y equals 8. Divide by negative 4, y equals negative 2. So, if I've done this correctly, when I solve for y in my other equation, I should also get out a negative 2. 3 times 1/3 is 1, minus y equals 3. Subtract 1 from both sides, negative y equals 2. Divide by negative 1, y equals negative 2. So that's my check. Our ordered pair is 1/3, negative 2. This should feel familiar to you. We did do this system of equations. We solved it by elimination a few slides ago in the previous video. So for another example, we're going to solve this equation, this system of equations, by the substitution method. Again, it will probably feel familiar to you. We did solve this exact same system with elimination. The reason I'm doing this is I want you to realize it doesn't matter which method you choose. They both have good points. They both have things that make them a little bit more challenging. In this specific example, we need to isolate a variable. You can choose which variable to isolate, and if you would like to clear your fractions beforehand, you may do so. What I'm going to do is I am going to isolate x in this equation. So, in order to do that, I'm going to multiply everything by 2. Not by 8, just by 2. I just want to get this x isolated. So, I will wind up with 2 times 1/2 is just 1, so I've got an x. 2 times negative 1/2 gives me a negative 1, so minus y, equals, now 2 times negative 1/8 gives me negative 1/4. To isolate x, I'm just going to add the y over. X equals negative 1/4 plus y. So now this chunk is what I'm going to plug into my other equation for the x value. So that is going to give me, I think I'll start up here, negative 1/2 times that x value plus 1/4 y should equal 1/2. A negative 1/2 times a negative 1/4 gives me a positive 1/8. So 1/8 minus 1/2 y plus 1/4 y equals 1/2. And at this point, you're probably freaking out because of the fractions. That's alright, we can clear them. Before we add anything, we can clear them. So this gives me 8 times 1/8 is 1. 8 times 1/2 is a negative 4. 8 times 1/4 is a positive 2. And 8 times 1/2 is 4. I'm going to combine like terms and move this 1 over. So negative 4y and 2y gives me a negative 2y. Subtract the 1 over, I get a 3, so y equals 3 over 2. I have found one of my two pieces. Now I still need to find the second piece. And it looks like I'm running out of room on this slide, so I am going to group these together, and I'm actually going to shrink them down. So bear with me one moment while I do this. I just want to shrink this down a little bit. It should still be readable to you. It just gives me a little bit more room on my page. Okay. So now, I need to find my x value. if y equals 3/2, plug that into one of the two equations. Again, it doesn't matter which one. I am going to plug back into this first equation that I used. So 1/2 x minus 1/2 times, that should be a negative 3/2 should equal -1/8. Again, we can clear our fractions if we'd like to. Multiply everything. Actually, before we do that, let's multiply here. Get my pen back. 1/2 x. Negative times a negative is a positive. That'll be 3/4 equals -1/8. And at this point, we can clear our fractions. So I get a 4x plus 6 equals -1. Subtract the 6 over, 4x equals -7. So x equals -7/4. Now you might be thinking to yourself, gee, that seems very familiar. It should be. Like I said, we did check this equation back on the previous slide. In fact, if you notice, in my calculator, I still have the check for this. So I'm going to drag that back over here. Let me erase. That's how we erase. By plugging my x and my y values into here, I get the -1/8. I had used this equation last time to finish solving, so I'm not going to bother checking this. That is not an option that you have on your tests. You always need to check things. Alright. So the steps for solving by substitution. Step 1, unlike elimination, it doesn't matter which form you're in, which form of the line. Step 1 is going to be pick a variable, to isolate. Now, if you'd like to, you may find it easier to isolate that variable in both equations. Let me rewrite that. There will be some instances in which that's the most helpful thing to do. Most of the time it'll be in a word problem, but we'll see how that goes. So once it's isolated, plug the remaining expression into the other equation. If you have isolated the same variable in both equations, set expressions equal to one another. So the purple goes together. You can't do this purple unless you've isolated the same variable in both equations. So this should give you one equation that you are working with one variable. So I know if I tap on this, that's going to move. So now that there is only one variable, solve. Plug the solved value into the original equation. Pick one, doesn't matter. So I could say into an original. Solve for the other variable. And then, of course, check in both equations. So now that we have these steps down, I want us to use our system of equations. We should be fairly familiar with this at this point. We're going to use this system of equations, and we're going to check it graphing by hand. In your homework, it tells you to solve by graphing. I would only like you to use it as a checking mechanism, and so we're going to check it by hand. And then I'll show you how to check it in the calculator by graphing. But it's kind of fun to do it by hand, if I can write. And so your first goal is to get this into y equals mx plus b. This one's already there. So we need to manipulate this equation a little bit. 6x minus 4y equals 10. Subtract the 6x from both sides, and negative 4y equals negative 6x plus 10. And divide everything by negative 4. Negative 6 over negative 4 is a positive 3/2 x. 10 over 4, especially that negative 4, is going to give me a minus 5/2. So looking at this vertical intercept being a fraction, I would like each tick mark to go by 1/2. So there's 1, there's 2. There's 1, there's 2. Here's my x, here's my y. So now that I have two equations that are in slope-intercept form, number 1, number 2, y equals 3x minus 3, I'm going to graph them both on this set of axes. We've done this slowly before, so I'm going to go fairly quickly through this. To graph the first equation, I need to start at negative 5/2. So that's negative 5 of these guys. 1, 2, 3, 4, 5. And then my slope says go up 3 and over 2. 1, 2, 3, over 2. 1, 2. Up 1, 2, 3, over 1. I lost it. It's hard to count these sometimes. So it should be right there. And I'm going to use my line utility. Make sure I get the red that I want. And get some nice arrows on it. This line will do something nice like that. And then get back to my pen, pick a different color. The other equation starts at negative 3, 1, 2, 3. And I'm going to go up 3 over 1, 2, 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, etc. And I'm going to graph it. And it's already set up for me, except I need my arrows. That's why it's not on mine. Okay, let's go to line. And this line is actually quite a terrible line that I drew. We'll do something like this. So when I'm looking at the graph, the part of the graph I'm looking for to find my solution is where the x value and the y value are the same in both equations. And it looks like that happens right down here. Now, based on my scale, that should be 1/2 and -1, 2, 3, 4/2, so -2. 1/2, -2. If I do this in my calculator, I will get something very, very similar. I still need these two equations. So I'm going to go into my y equals value. I want to clear these out. I am going to go in and type in y equals, too far, alright, y equals 3/2 x is right here, minus, and again in parentheses, 5/2. And then the second equation is going to be 3x minus 3. I believe I have a standard window set up, but that's not as demonstrative as I would like it to be. I want to actually get a closer window here, so I'm going to go to Window. If this is 2, 3, 4, 5, I have a -5/5 window. So that's what I want to turn this into. So I'm going to go -5 to 5, and my scale I want to go by 1/2. My y as well is going to go -5 to 5 with a scale of 1/2. Now I hit graph. So there's one of my two lines, and there's the other one. Now, your calculator is very smart, and it will calculate the intersection of these two lines for you. So go into Second, Calculate. It's option right above Trace. And option number 5 says Intersect. So I'm going to hit Enter on 5. And then it's going to ask me a few questions. The first one is first curve. That's just saying, is this equation the one you really want me to match to? So it's a way to double check that you didn't mis-enter something into your y equals screen. So hit Enter. And it's going to say second curve, and again, check to make sure that's the other curve you want it to enter. Hit Enter again, and it asks you to guess. You never care to guess on a linear equations system. So hit Enter one more time. And the solution it gives us is not 1/2. We were supposed to be at 1/3. So that's not a problem. Don't freak out. It just means that we were estimating. This 1/2 was an estimate. Because we solved this by graphing, or checked it by graphing. Now, if I knew the solution to begin with, and I graphed this, I would recognize, okay, by hand, an intersection being between 1/2 and 1/3 would be very, very hard to notice. So don't panic if I ask you to check by graphing, and your graph, especially by hand, is off a little bit from your solution. Your calculator should get pretty close, but by hand, don't panic, it's fine. If you need to see how to graph that again, feel free to rewind the video. I believe that was it, and we are done. That is section 4.1, Systems of Equations. The next video I'll be doing is section 4.3, when we're solving applications of systems of equations.